differentiation. Implicit differentiation. Now, probably the best way to start off learning how to take derivatives implicitly is to understand the following concept. If somebody said to you, find the derivative of y equal x squared, this is what you're really doing. The derivative of x squared is 2x. What you really weren't ever told is the following. You're taking a derivative with respect to x, that's where it goes in the bottom, and x squared is in terms of x, so dx goes on top. The derivative of y is 1. We're taking a derivative with respect to x, and this here is in terms of y. Every time you take a derivative, you end up with pieces like this. Of course, this is 1, and on the left side, 1 times dy dx is just dy dx. On the right-hand side, it's 2x times 1, or 2x. For example, if you were asked to find dy dt, that means the derivative with respect to t. If we said that y was equal to t cubed, then the derivative of y is 1, just like the derivative of x is 1. In the numerator, write down d followed by the letter that you just took, the letter of the term you just took the derivative of, which is y. And in the bottom, you put dt, because you're asked to find the derivative with respect to t. And of course, 1 times dy dt is just dy dt. The right-hand side, the derivative is 3t squared. This is in terms of t, and we've asked you to find the derivative with respect to t. And this is going to cancel out to 1. And 3t squared times 1 is 3t squared. There's your answer. Now, for the same exact function, suppose I didn't ask you to find dy dt. Suppose instead I said, find dy dx. Okay. Find dy dx for that same y value. For y equals t cubed. Well, the derivative of y is 1. It's in terms of, well, that's in terms of y, with respect to x. And 1 times dy dx is dy dx equals. The derivative of t cubed is 3t squared. This is in terms of t, so dt goes on top. In the bottom, with respect to x. And there's your answer. 3t squared dt dx. Every time you take a derivative, you end up with one of these. Sometimes, like on the right-hand side, sometimes they cancel out. That's called a coincidence. It's still there. It's still there. Every time you take a derivative or something, you end up with, dy dx, dy dt, dq dr, d something over d something. Sometimes they cancel out. Not always. Okay, so let's try a more complicated problem. Find dy dx. That is the derivative with respect to x. The derivative of y with respect to x. Find dy dx for x cubed plus 2y squared is equal to 7. Well, the derivative of x cubed, like always, is 3x squared. X cubed is clearly in terms of x, and we divide it by this, always by that. So this cancels cancel out to 1. Plus, the derivative of 2y squared is 4y. We're taking a derivative of something in terms of y with respect to x. And this equals, the derivative of 7 is 0. Now, whatever I put here, 0 times it is 0. I can say that's a function of y, and then get dy dx. A constant is a function of y. Y can equal 7. That is, I can say that's a function of y. Or I can even say, instead of that, I can say it's a function of x. Either way, 0 times it is 0. Now, we have 3x squared plus 4y dy dx. This is equal to 0. And we want to solve for dy dx. These are their three terms. I'm going to solve for the term that has dy dx, namely this one, by bringing this to the other side. So positive 4y dy dx is equal to negative 3x squared. And then I'm going to take the 4y and put it on the bottom. That is, I'm dividing both sides by 4y. On the left side they cancel out, and the right side they don't. So, dy dx is equal to negative 3x squared over 4y. That's dy dx. Try another one. Suppose you have 5x squared y minus 3y to the fourth, and this is equal to xy cubed. Is equal to xy cubed. Okay. So, okay, and we want to find dy dx. Find dy dx. Now, here is the product. You have to use the product rule. Now, you have two ways of thinking about 5x squared y. You can think of it as 5x squared times y. One can use the product rule with these as the two functions. Or, I don't know why you would think of it this way, but you can think of the 5 as being multiplied by the y and use the product rule there. Or, with this, because this is not a bad way of thinking about it. This is not bad, but it's strange. If you want to put the 5 with something, why not leave it right where it is next to the x squared? And the last way is, you can think of the 5 as you can factor out the 5. That is, to take the derivative of all of this is 5 times the derivative of that. Use a constant multiple rule. Okay, we'll do it this way. So we're going to use the product rule. You're going to think of this as one function and that as the next. Product rule says take the derivative of the first function, which is 10x. It's in terms of x what we took the derivative of. I agree that 5x squared is in terms of x and y. But we only took the derivative of 5x squared right now. It's in terms of x, and you're being requested to find the derivative with respect to x. So it's the derivative of the first times the second. Why am I not writing dy dx? Because I didn't take the derivative of the y. Plus the first function, which is just 5x squared. I don't take the derivative. I don't put those d over d stuff. But now I'm multiplying by the derivative of y. Just like the derivative of x is 1, the derivative of y is 1. And y is in terms of y, and we're taking a derivative with respect to x. A minus 12x cubed, make that 12y cubed, and it's in terms of y with respect to x. And this is going to equal, now we have our product here, x times y cubed. The derivative of the first, which is 1, it's in terms of x. This here, x, is in terms of x with respect to x. The derivative of the first times the second, y cubed. Now we reverse the game. It's just the first, and now we take the derivative of the second. The derivative of 3y cubed is 3y squared. Y cubed is in terms of y with respect to x. And all I'll say is that this over here cancels out to 1. So let's try to write everything on one line. Let's clean it up a little bit. This here is just 10xy plus 5x squared times 1 is just 5x squared times dy dx. So 5x squared dy dx minus this. Nothing really to clean up there. 12y cubed dy dx. And also, on the next line, the dx cancels. Now we have 1 equals. We have 1 times y cubed, which is y cubed. That's there. And here we have plus. We have 3xy squared dy dx. Okay, the calculus is over. We want to solve for dy dx. So let's find all the terms. It's very, very simple to find the terms. Terms are separated by addition and subtraction symbols, and I guess equal signs. Now, this term right here has dy dx. This term has dy dx. And the very last one has dy dx. I want to get on one side of the equal sign all the terms that have dy dx. Now if you think about it by how we're designing it, since all the terms on, say, the left side are going to have dy dx, I hope it's clear that we'll be able to factor out dy dx. Well, we'll do that next step. So I'm going to go term by term. The first term goes to the other, dy dx is to the left. So the first term crosses over the equal sign, and the sign changes. It's understood to be positive because there was no sign, it changed. The next term is the dy dx. I leave it just where it is. Positive 5x squared dy dx. The very next term, dy dx. The sign, so I'm not moving it across the equal sign. The sign does not change. The next term, y cubed, and understood positive y cubed, it stays just where it is on the right-hand side. I don't change the sign. Only dy dx has come to the left. The next and last term, I have to cross over the equal sign to get it on the left side. It's plus, now it's minus. 3xy squared dy dx. Now if you or your teacher write y prime instead of dy dx, that's fine, because y prime is dy dx. So you can write y prime. Okay. Now, as promised, every term on the left side has dy dx. On the right-hand side, no dy dx. So I factor out dy dx. Dy dx times 5x squared is that. I mean, basically, just don't write down dy dx because we factored it out in front. Copy down from here to the equal sign everything except what's crossed out, like 5x squared and a minus sign, and a 12 and a y cubed, and a minus 3xy squared. And the right-hand side won't change. Although, I hate for the first term to be negative. Sometimes you might lose it, you might not see it. So I'm going to write the positive y cubed first, minus 10xy. Okay. And then I'm just going to divide by this on both sides. On the left side it cancels out, and all I have is dy dx. And on the right hand side, when I divide by this method, it does not cancel out. Okay, now the instructions might have said, instead of just find dy dx, it might have said find dy dx at the point well, if x is 1, let me think what y should be. We have 5y minus 3y is 4 is equal to y cubed. If only I wrote 2 on the right hand side. 2xy cubed. Okay, we'll do that next problem. Okay, so just find dy dx. Now, let's try another one. Now, sometimes you can be very, very clever. You don't have to use any calculus at all. If somebody gives you the equation of a circle, for example, somebody gives you the equation of a circle. Okay, remember this here is the same as square root of 5 squared. And the equation of a circle is written that way, where the radius is r. The radius is what's being squared. So the radius is the square root of 5. But that doesn't even matter. Basically what we have here, we have a circle, centered at the origin. You want to put square root of 5 to the radius, fine. You don't need it, and you'll see in a moment I'm not using it at all. And you want to know the slope of the tangent line at any point. Well, if I call this point xy, then you make a little right triangle. And since the x value is that means this horizontal distance is x, and this vertical distance is y. So then the slope of this line right here, the slope of that line is the change in y, which is y, over the horizontal change, which is x. Okay, but we want the slope of the tangent line at any point. Well, here's the tangent line. Notice that this line and the tangent line is perpendicular. Remember from elementary algebra, the slope of this line must be, flip this over, x over y, to the minus in front. That's the derivative. Now remember, that's the slope of the tangent line at any point. I mean, if I would have taken this point and called the point arbitrarily xy, I would have gotten the same slope. So I'm telling you that the derivative of y with respect to x is negative x over y, and I didn't use calculus. But let's do it using calculus. We'll do that on the right side. X squared plus y squared is equal to 5. And you're asked to find dy dx. Okay, find dy dx. That is, we're taking a derivative with respect to x. Okay, the derivative of x squared is 2x. That's clear. This is what we're taking the derivative of. It's clearly in terms of x, and we're taking it with respect to x. Plus, the derivative of y squared is 2y. What we're taking the derivative of is in terms of y, and we're taking it with respect to x, equals the derivative of 5 is 0. First thing I'll do is I'll divide both sides by 2. And now I solve for this. That is, I bring this to the other side. So y dy dx is equal to, this was understood to be positive. When I bring it over, it becomes negative. And the dx basically cancels out. Now, if killing off the 2's were a little bit too premature for you on the last line, well, there's the 2. There's the 2. Now I divide both sides by 2y. Divide both sides by 2y. And if you didn't see the 2's canceling out before, I hope now it's as clear as day that the 2's cancel out. On the left side, so does the y's. And you conclude that dy dx is nothing more than negative x over y. Okay, let's try this one. X cubed plus y cubed equals 10. Or any constant. X cubed plus y cubed equals 10. Find dy dx. Actually, let's make this 9, okay? So, the instruction is find dy dx at x is 2, y is 1. Notice that 2 cubed is 8, plus 1 cubed is 9. Okay, so x, so the point 2, 1 is on the curve. If the curve looks like this, for example, and here is 1, 2 on the x, and here is 1 on the y, we're looking for the slope of this tangent line. That's what we're looking for, the slope of that tangent line. Derivative at a point is the slope of the tangent line at that point. Okay, so let's take the derivative. The derivative of x cubed is 3x squared. X cubed is in terms of x, and we're taking a derivative with respect to x. Fine, that cancels out. Plus, the derivative of y cubed is 3y squared. Y cubed is in terms of y with respect to x, and this is equal to 0. Derivative of 9 is 0. These are the terms, separated by the addition symbol on the left side, and it's only addition and subtraction symbols in the right-hand side. Since there were none, there's only one term in the right side. Alright, so we're going to leave this term alone. It's positive 3y squared dy dx. But this 3x squared I bring to the other side is negative 3x squared. And then I divide by what I don't want. I just want dy dx. So I divide by 3y squared. 3's cancel out, the y squared cancel out. 3y squared. The 3's cancel, so I'm left with negative x squared over y squared. So we don't want that. Now, dy dx is a function of x and y. To know what dy dx is, that is, if the right-hand side equals 10, then dy dx is 10. The right-hand side equals 2/3, then dy dx is 2/3. If we know the right-hand side, we know what dy dx is. But to know the right-hand side, you need to know what x and y are. That is, dy dx is a function of x and y. And it equals what it equals, namely negative x squared over y squared. Well, we want dy dx at the point 2, 1. X is 2, y is 1. So it's negative 2 squared over 1 squared. It's negative 4 over 1, which is negative 4. The slope of the tangent line at 2, 1, negative 4. Let's do some more where you have products and a power rule problem. How about we do this one? You have that x squared plus 3, x squared y plus 3y squared to the second power is equal to x plus y. Exactly what you have. So on the left-hand side, you have a function to a power. We know how to handle that. Keep the function the same. Bring down the power, make the new power 1 less. 2 minus 1 is 1. Then multiply this by the derivative of what's inside. So since it's a sum, we take the derivative of x squared y, then we take the derivative of 3y squared, and we add them up. So the derivative of x squared y, the derivative of x squared y, and I'm asking you to take it with respect to x, well, it's a product rule. So use a product rule. So it's the derivative first, which is 2x. Now x squared is in terms of x, and we're taking derivative with respect to x. That's the derivative of the first times the second. Now we reverse the order. We keep the first the same, and now we take the derivative of the second. The second term is y. The derivative of y is 1. Y is in terms of y, and we're taking a derivative with respect to x. That's the derivative of x squared y. So I'm going to write it down right here. And I'll say that this cancels. So I get 2xy plus x squared times 1 is x squared dy dx. Plus the derivative of 3y squared is 6y. 3y squared is in terms of y with respect to x. That's the derivative of what's inside the brackets. And this equals the derivative of the right-hand side. The derivative of x is 1. It's in terms of x with respect to x. Plus the derivative of y, which is 1. And y is in terms of y with respect to x. Okay, so let's clean this up a little bit. Now, the 1 you don't need to even talk about. I can distribute the 2, so I get 2x squared y plus 6y squared. And all of this is being multiplied by 2xy plus x squared dy dx plus 6y dy dx. And this is equal to, on the right-hand side, their dx cancels, and we get 1 plus 1 times dy dx is just dy dx. Okay, the calculus is done. Now the messy part, the algebra. You're not perfect with algebra, you will be at the end of this semester. Okay, so let's just review their pieces. It's this times that, which is, alright, so let's just take this 2x squared y plus 6y squared times 2xy. Plus the same thing, 2x squared y plus 6y squared multiplied by, well, you know what, since both of these have dy dx, why don't we say it's plus x squared plus 6y dy dx. I backed it out to dy dx. So all of this gets multiplied by what that is. Times x squared plus 6y dy dx. And the right-hand side doesn't really change. Okay. So I'm trying to decide if we should really multiply out, but let's do it. this times this is 2 times 2, x squared times x, y times y, plus 6 times 2 is 12 times x, and y squared times y is y cubed, plus 2x to the 4th times y, plus 12 x squared y squared. Now we distribute the 6. You get plus 6 x squared y squared plus 36 y cubed. And all of this is dy dx. And it equals 1 plus dy dx. Now I'm going to bring all the terms that have dy dx to the left side. Well, this is one of them. So we have 2x to the 4th y plus 12x squared y squared plus 6x squared y squared plus 36y cubed. And then on the right side, I have an understood 1 dy dx. So I bring that to the left as minus 1. And everything gets multiplied by dy dx. So far, I dealt with this piece and that piece. So the right-hand side has 1, and this remains on the left side. I'm going to bring it over to the right side. So the right side is 1, and then I take away the 4x cubed y squared, and I take away the 12x y cubed. And then basically take this, take how many dy dx's you have, and put it underneath here. And that's what dy dx equals. It's lots of algebra, but it's definitely doable. You should definitely be able to do these types of problems. Okay, how about a problem like this? Suppose you have x plus y squared, and this is equal to x squared plus y squared. Now, if this were my problem, I would square this. I like to call this the first and the second. You get the first squared plus 2 times the product of the first and the second plus the second squared. And this is x squared plus y squared. Well, I can take away x squared from both sides. I can take away plus y squared from both sides. So what I get is 2xy equals to 0. 2xy equals 0. Now for product. I'll think of 2x as the first function and y is the second. The derivative first, which is 2. 2x is clearly in terms of x, and you're being asked to find the derivative in terms of x. The derivative first times the second. The second is y. Y no dy dx or anything like that? I didn't take the derivative of y. Plus, the first function is 2x times the derivative of the second function. The derivative of y is 1. Y is in terms of y with respect to x. Give your product rule on the left side. The derivative of 0 is 0. Okay, so I want to solve for this. That is 2y, let's see, y dx cancels, plus 2x dy dx is equal to 0. So like I said, I want to solve for that first. I bring the 2y to the other side as negative 2y. So 2x dy dx is equal to negative 2y. And now I divide by 2x, and the 2's cancel and the x's cancel, and all I'm left with is dy dx. I do the same to the right hand side. The 2's cancel, and dy dx is negative y over x. There's the derivative. Of course, you could have done it the much harder way. You could have said, well, derivative of this to the second power, the power rule. Keep x plus y the same, bring the power down, make the new power 1 less. And then you take the derivative of x plus y. With respect to x, the derivative of x is 1, plus with respect to y, the derivative of y is dy dx. Equals the derivative with respect to x of x squared is 2x. Because their dx dx is going to cancel. Plus the derivative of y squared is 2y dy dx. And then you clean this up for a bit. So you have 2x plus 2y, I just distributed the 2, times 1 plus dy dx. This is equal to 2x plus 2y dy dx. Now I distribute on the left side. 2x times 1 is 2x plus 2x dy dx. 2x dy dx. Now I distribute the plus 2y with the 1, and I get plus 2y, and then the plus 2y with the dy dx. And this is equal to the right hand side. This is equal to 2x plus 2y dy dx. And coincidentally, both sides have 2x, so I can take them away, and both sides have 2y dx, 2y dy dx, so I can take it away. So what survived on the right hand side is 0. So let's move over the equal sign a little bit. And what survived on the left hand side is this mess. 2x dy dx plus 2x, excuse me, plus 2y. But if I'm not mistaken, that's just what we got earlier. Remember, I can switch the order of those two. Addition allows me to switch the order. That is exactly what I got on the right hand side. So you can just follow from there down to get what dy dx is. Okay. Let's try one more. Suppose you were asked to find the second derivative. Find the second derivative of y with respect to x. For x squared plus y squared is 0. Or 10. So the derivative of the left side is 2x. The derivative of x squared is 2x plus the derivative of y squared is 2y times y prime. And the derivative of the right hand side is 0. Now, we want to find the derivative. Let me see something, please. see how they're also different. So you can take the derivative of both sides again, or you can solve for y prime. Let's bring this over and solve for y prime, better known as dy dx. So plus 2y dy dx is negative 2x. We divide by 2y, just like we did earlier. This is the same problem we did earlier. So dy dx is equal to negative x over y. Now we want to take the derivative again. The derivative of y prime. Remember, this is y prime. The derivative is the second derivative, y double prime, which we denote this way. Or your book or teacher calls it y double prime, fine. The derivative of the left side is y double prime. This time I'll think of the minus sign, that is the minus 1 is being factored out. Equals negative 1 times. Now we have a quotient, so we use the quotient rule. The derivative of the top, which is 1. Derivative of x is 1, times the bottom, minus the top, times the derivative of the bottom, which is dy dx. And all of this gets divided by the bottom squared. So we have the second derivative with respect to x is equal to. Now, when you have a difference like a minus b, when you put a minus in front, you get b minus a. Minus a is right there, and minus negative b is plus b. That is, it's really this minus that. It's x times dy dx. But dy, maybe it doesn't even pay to do that. Okay, let's do that. Dy dx is negative x over y minus 1 times y is y. All of this is over y squared. So what we have is negative x squared over y minus y over y squared. So what I'm going to do is I'm going to multiply each term by y, because I don't like that y. In the numerator, there should be no denominator. In the denominator, there should be no denominator. So I'm going to multiply each term by y. So again, negative x squared, because the y's cancel, minus y squared over y cubed. And then I can factor out a minus sign. And I get negative x squared plus y squared over y cubed. Now the reason I wanted to do this problem is this is not done. I really ran out of space, so I'm going to put it right here. This is really negative 10 over y cubed. That's the final answer. Why is that? Because we were given that x squared plus y squared is 10. So I can cross out x squared plus y squared and put 10. Don't forget the minus in front. Okay, that completes the section on implicit differentiation. Remember, every time you take the derivative or something, you have one of these derivative terms, dy dx, dr ds, dy dy, dx dx. Every time. If you don't take the derivative, you don't get one of those.